Okay, hi everyone. So my name is Sam Miller and I am partners with Jake Anderson. And today we will be presenting our progress on the Girl Scout robot project. So our agenda for the day consists of a project background and problem statement, design and directions, evaluation of solutions, verification of validation, an implementation plan, and conclusions. So first of all, we want to give a little information about our sponsor. We are working under the management of Girl Scouts of California Central Coast, which has offices and program centers from Ventura to Santa Cruz County. And we're also guided and supported by the Cal Poly IME department, and our project and budget is sponsored by the Girl Scouts of the USA. The project originated due to the fact that women are underrepresented in STEM fields, and the Girl Scouts of California Central Coast desire to contribute and improve this issue. The vision for the project was developed after seeing life-size Lego statues and displays in the Mall of America, which attracted children and provoked interest. So here are some statistics to support the claim that women are underrepresented in STEM. As you can see, women comprise the majority of the college-educated workforce, but only 29% of the STEM workforce. Additionally, only 13% of all engineers are women.
For our problem statement, there is an absence of a current design and process to manufacture a robot chassis, which needs to connect with and allow for communication between the ME team's arm and the CPE team's tablet. We're working on cross-functional teams, so the ME team or the arm team is responsible for making the movable arm, which will have the movable hand that makes the Girl Scout symbol. The CPE team or the tablet team is providing a tablet as well as a custom program to run all the robot's functions. Us, the IME team or body team, are responsible for designing the robot's chassis, which includes its aesthetics, its durability, its functionality with the other components, and how easy it is to manufacture. For the design specifications of our component, it needs to be roughly 5 feet tall. The exterior needs to be made of or resemble Legos. The aesthetic design needs to resemble a Girl Scout roughly. The design needs to be durable. It must integrate with a power source for our electronic components. And we need to provide instructions so they can manufacture this one as well as more in the future.
So here we have some research about the project need in context, or in other words, an examination of a current state. And from our research, we learned that a large determinant of choosing certain subject paths is confidence in one's abilities to succeed, which comes from encouragement and early learning experiences, and that is what the project aims to accomplish. Additionally, Lego robotics have been used in the past as fun and exciting ways for students to learn about STEM because they allow for all ages to gain hand-on experience and build confidence in their abilities. We also conducted research on the current state related to possible designs and strategies. So from this research, we learned that our statue should be hollow in order to decrease weight. A simple pose will accommodate internal support installation, and that sub-assemblies can be very beneficial for larger builds such as ours. Additionally, we were warned of the time it takes to assemble a life-size Lego structure, and we were exposed to the other functions that robots may have in stores besides attracting and interesting customers. So here we have a fishbone diagram that we created early on to help us visualize the current state of our project, the task we will need to complete, and the questions that need to be resolved.
For our design directions, some of the decisions we had to make was what CAD program to use to make the Lego parts. We ended up going with Bricklink Studio because of what it allowed. The tablet location, which we decided on the head after talking through it with the Girl Scouts. For the mobility, we selected a 4-wheel design, and then we needed to be able to mount the arm and the tablet, and we selected a mount with the ME team, and we selected a tablet mount with the CPE team. Some additional design considerations we had to do was what sort of internal support, glue options, and aesthetics, which we will evaluate in future slides. So evaluating the glue, we had 5 options: no glue as a control, super glue in liquid and gel form, and then 2 spray glues, a Lego specific one and a Gorilla Glue. Both of the spray glues really didn't do what we wanted from them, so they were out. And then the no glue didn't add the additional support we needed, so we were down to the super glues, which could hold up to 20 pounds before breaking, which was good for our needs. And then we narrowed it down to the liquid because it could cover a lot more area than the gel could. Evaluating our internal support, again, we had no internal support as a control, and then wood, PVC, and metal. We were looking into wood and PVC the most and went with wood because it worked with the IME team's mount the best. And then evaluating our aesthetics, we came up with a bunch of different ideas for what the Girl Scouts could potentially want and then talked it through with them so that we came to a final conclusion of a skirt in khaki, white shoes, a green short sleeve shirt with the Girl Scout symbol, the head, which will be mounting the tablet with hair, and then the skin tone of yellow to mimic the traditional Lego skin tone.
So going off of this, in order to verify and validate our proposed final solution, we start off by sending our sponsor rendered images of our design to confirm that it met their standards. And additionally, because safety is our top priority of ours, we set up an experiment to test the force required to tip our structure. So we created a model of our final structure by adding 65 pounds of weight to our internal support. And then we used a fish hook scale to record the amount of force it took at the top of the support to lift the wheels off the ground while adding weight to the base incrementally. And so for the most additional stability for weight added, we recommend adding 15 pounds to the base. Additionally, despite our recommendations of adding additional weight to the base, like any large and heavy structure not bolted to the ground, there is still a concern of it tipping over. Because of this, we recommend that the structure should be placed near a wall and it should have a barrier in front or around it. Here we have the price breakdown of our final design. So the base costs roughly $80, the Legos cost around $1,250, the glue costs around $200, which brings us to a total of around $1,550.
For our implementation plan, we have a scheduled build day where the Girl Scouts will be involved with building the structure as well as the ME team's arm. And the Girl Scouts will be able to meet the three teams as well as see their contributions, and they'll be able to provide feedback on how good our instructions for constructing it is, as well as their experience with working on this project with us. For our building instructions, we designed the Lego instructions mirroring typical Lego instructions, which a lot of people should be familiar with. And we designed it in sub-assemblies so that most people can work on it at a single time. And then for our more traditional components like the internal support, we've made more traditional engineering drawings. For our conclusions, the design of the robot has been completed with appropriate instructions. The structure has not been fully built though because of supply chain issues on Lego's end. To prioritize safety, we recommend that the structure be treated with caution and be placed in an area where it's least likely to be tipped on accident. And then small adjustments to the design can be made with relative ease if the Girl Scouts ever decide to change anything.
Thank you.